this video, I'm going to show you that 2 plus 2 actually equals 5 and not 4, as you've been taught to believe. And then I'm also going to show you that 2 equals to 1. This way is going to be numerical, and in this way there's a little bit of algebra, so it's kind of two sides of the coin. Of course, I'm joking when I say as a literal statement that 2 plus 2 equals 5, but I'm looking for someone to tell me what mistakes I made and leave it in the comments. So disclosure here, I'm not going to put the correction at the end of the video. I'm going to leave them as open questions, and then hopefully someone will be able to enlighten all of us as to what mistakes I made. So let's begin with an assumption. So I'm going to write here, we know that, we're going to say 2 plus 2 equals 4. All right, so I'm going to rewrite this, 2 plus 2 equals 4. But what I'm going to do in addition is I'm going to add a 9 over 2 to each side. So no problems there. 2 plus 2 still equals 4 because we can minus 9 from 2 from each side and we get back to our original equation. So no problem so far. Continuing on here, I'm going to bring this guy over to the other side. So we're going to have a 4 minus 9 over 2, and then we still have our plus 9 over 2. Very good. And then we have, what I'm going to do now is I'm going to, in brackets, I'm going to put the 4 and the minus 9 over 2. I'm going to put them, I'm going to square that, but then I'm also going to put it under a square root. So they'll cancel with one another, leaving us with the 4 minus 9 over 2. And then we still have the original plus 9 over 2. So next, what I'm going to do is I'm just going to expand out this expression within the square root. So I'm not changing it, I'm just expanding it out. So once again, if you got the square root of the expanded value, again, it would cancel, giving us our original equation. So that's going to equal the square root of 16 minus 36 plus 9 over 2 to be squared. And then we have our plus 9 over 2. So continuing on, we still have our 2 plus 2. Now I'm going to keep the square root. So instead of having the 16 minus 36, which will give us a minus 20, right? So 16 minus 36 will give us a minus 20. What I'm going to write instead is 25 minus 45. And then we still have our 9 over 2 squared here. All the way over, actually it was meant to keep this as 9 over 2. And what this allows us to do then is the following. We're keeping in the square root. So 25 we know is 5 squared. And then a way of rewriting minus 45 would be minus 90 over 2, because 90 divided by 2 is 45. So no issues there. And then we still have our 9 over 2 squared. And that's all going to be under the square root. And again, we still have our plus 9 over 2 on the outside. But what you notice now is this here is an expansion of the following. 5 minus 9 over 2 squared. So if you squared this expression, you would get this value. So they're equal. And once again, we have our 9 over 2 on the outside. Now what you may have noticed, this is where it gets interesting. Now we have a squared expression underneath the square root. So we can then just cancel the squared with the square root. That leaves us with 5 minus 9 over 2. And then we still have our plus 9 over 2 here. But we can just cancel these with each other. And then this leaves us with 2 plus 2 equals 5. This one's going to be algebraic, so we have A equals B. So we just set that as a statement. We set B equals to A is equal to B. And what I'm going to do is I'm going to keep this A, and we're going to multiply by A here. And what we do to the left of the equals, we have to do to the right. So then on B, we're also going to multiply by a. So let's just tidy this up a bit. So a multiplied by a is a squared, and then we're still left with our b times a. Next, what we're going to do is we're going to minus b squared from each side. So we have b times a, and we're going to minus b squared from both sides. Well, simplifying this is simply going to give us a plus b, a minus b. And then in this one, we have a variable that's in both expressions, so we can take out this b, and that will leave us with an a minus b, because one of these b's was taken out here to be the coefficient of this expression. Well, now we have this expression on both sides, so they can cross out with one another. So then that leaves us with a plus b equals b, but then we said from the start that a is equal to b. So then if we just substitute for a, we substitute b in as they're the same. So then we have b plus b equals b. Well, that leaves us with 2b equals b, and then divide across by b, that gives us 2 equals 1. So now if you spotted the mistakes or the little manipulations that I made in order to make these two false statements seem true, put it in the comments, which will save more people a lot of time doing it for themselves, and it's good to get involved in that way. So I hope you enjoyed the video, and if you could subscribe or put the notification bell on or send this to your friends, see if they can figure it out, that would be very much appreciated. So thanks, and see you in the next video.